Okay, as you notice, there's a lot of slides, so I'm going to try to make this as quick as possible. Okay, this is 2.2 frequency distributions, and we're going to focus the most on histograms and ways to make histograms and related topics. Okay, so we're going to organize raw data, make histograms, and then do a whole bunch of different things with the information. So basically, what is a histogram? It is a type of a bar graph that uses quantitative data. Okay, except it has a few different things compared to a bar graph from the last section. Okay, so the bars have equal width and always touch. So instead of being apart, they're always going to touch. All right, so there won't be any gaps. The width of the bar represents a quantity. Okay, and we're going to call this the class width, and we're going to talk about that in a second. But this is going to be some quantity. It might be 2 units. It might be a weird number, and we'll kind of show you all that in a second. The height of the bar is the frequency of the variable, so that still talks. It's no different than a bar graph in that sense. Okay, so steps to create it. This might be a good slide to kind of keep in mind. All right, first of all, you're going to need to decide on the number of classes. Many times I'll say 5, and many times this will be given to you in the problem. 5 up to 15 it depends upon the situation. Find a convenient class width, and I'll show you how to do that. Organize the data into a frequency table. Gather your data, figure out how many entries are in each class is what we call it, and then find the midpoints. You all know how to find a midpoint. It's essentially an average. And then determine the class boundaries. That's what we're going to put on the actual graph itself, and then you will sketch the histogram. So tying this all together, how does this work? To find the class width, okay, what we call as a class width, you need to find the largest and the smallest data value. Find the difference between them. So we'll show you an example about that, but find the difference of them, and then divide it by the number of classes you want. And this will be given in the problem. Alright, so that is the first step. Always, 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 just so that things work out, you have to increase the value to the next highest whole number. So when you do this calculation, you must round up. Even if you get an answer that is exactly 5.0, you must round up to 6, or else your classes won't work up. So even if you end up doing this calculation and it's a nice round number, you must round up to the next whole number. Okay, so here is raw data. Okay, this data is information of the distance to drive home from work. From, I don't even know how many people, I'd have to look at it. Okay, so that's what we need to do. We're going to use 5 classes. Notice if you sift through here, your lowest number is 0, your highest number I believe is the 24.7, even though I can't see it right now. Okay, and what you're going to do is highest minus the lowest divided by 5, you get 4.94. You have to round it up to 5. So your class width, okay, is 5. Now what does the class width do? We'll show you that in the next slide when we start doing the data and tallying stuff. Okay, frequency tables, you're going to be asked to do this a lot. Okay, it's a method of organizing data. Okay, it shows the distribution, or essentially how many things or data are in each class or interval. All right, so determine the class width, we just did that. So in our example it was 5. And then create the classes. How does this work? The smallest data value becomes the lowest limit of the first class. So in our example, the shortest distance was 0. So we're going to start the first class at 0. Okay? And then add class width to get the lower limit of the next class. So I'm going to add the 5. So it'll become 5, and then 10, and then 15, and then 20. Those are going to be our lower limits of all 5 of my classes. Now what happens is you can't go 0 to 5 because 5 is going to be the next lowest one. So I go back and I think it was by 0.1. So I'm going to go 0.1 lower. So 4.9 and so on, 9.9. This is going to become your class. Any number between 0 and 4.9 will go in the first class. 5 to 9.9 will go in the second. All the way down to 20 to 24.99 or 0.9. That should be the highest number, better fall in that last class. Okay, and what we're going to do is you'll tally the data, and then each number better fall into exactly 1, not on the borderline. It better go into 1 exactly. And then midpoints, we all know how to find midpoints. Okay, so this is just more information. Lower class limit and higher class limit I already talked about. Class width, I just showed you. This is between the lower class limit of one class to the lower class limit of the next. Okay, it doesn't have anything to do with the highest number. It goes from lower to lower. Computing midpoint, if you don't know, add them together, divide by 2. Okay? Class boundaries. Now this is what we use to actually graph, is we need the class boundary. And all you do is you take the upper limit and the lower limit of the next class and find the midpoint of them, the middle ground. And I'll show you all of that in a second with this concrete example. So going back to that original table on like the whatever slide that was, the 5th slide, okay? I tallied them all for you. So from 0 to 4.9, which I just showed you, there were 6 data entries. And you can go back and check if you want. There were 5 in the next class, 4, 5, and 5. Okay? This is a frequency table. That's all it is. Tallying it up from whatever class you are and what's the frequency in that class. That's all we're looking for. Okay? The midpoint, you take your high and your low and you find the middle. If you go 4.9 plus 0 divided by 2, you get 4.25. What's kind of neat about your midpoints is the midpoint of the next class, if done correctly, better be how many units apart? 5 units apart. And guess what? You can kind of cheat and just add 5 instead of doing all the calculations over again. This is the way it's going to work, because that's your class width. Your midpoints better be the same distance apart as your lower limits are. So that's just something to keep in mind. You can just add your class width in there. Okay? Class boundaries. What are these used for? This is how you actually graph it on the actual histogram, which kind of sucks because the numbers aren't necessarily convenient, but it's the way they want it to happen. If you do this under calculator, it'll be the same thing. Okay? How does this work? I said the boundaries are the highest number of one class and the lowest number of the next, and then you divide them by 2. Or essentially find the middle. Add them together, divide by 2. Well, what's the middle of 4.9 and 5.0? 4.95. Okay? So then this is going to be 4.95 as the highest. 2. Well, now what if there's nothing below? Well, notice that you were just 0.05 apart, so we have to go to negative 0.05 to 4.95. These numbers should be the same, which means this should be 9.95 because that's your boundary. You're never going to have a number fall there. That's why they're going to always be weird numbers, because you don't want a number to fall on your boundary because we don't know exactly where it's supposed to go. And then the next one should be 14.95. And if you notice something, these are going up by 5s as well. Your class width comes back to show up in all of these. Okay? So then if you keep going, 14.95 to 19.95, and then 19.95 to 24.95. So all that comes full circle. So these class boundaries are what you're going to actually graph your histogram with. Okay? To make the histogram, okay, you need to make the frequency table. We already have done that. Place the class boundaries on the horizontal axis. And it's pretty easy. You just put it on there, and if you flip to the next slide, that's what it looks like, and you can look to the right. Okay? For each class, the frequency table, the bar is extended between them, and it's going to connect, and then the height of the bar is however many entries are in there, or i.e. its frequency. So here's an example. Here's our frequency table, and the corresponding histogram next to it. Okay? So notice the frequency table has your class with 0 to 4.9, but on the table, on the actual histogram, you go with the boundaries. That's the difference. Okay? Your frequencies go up, and they just correspond to each one. So this would be 6, 5, 4, 5, and 5. All right? So that's kind of how that works. Common shapes of histograms. I'm going to go through these quickly. Symmetrical. Any type of way you can fold it and it's a mirror image, it's symmetrical. Uniform, all of them are the same. How often that happens is so rare. Here's the ones that happen the most. We will talk about this. Skewed left. I think about it as a dinosaur tail or whatever you want to think about it. It's going down to the left. It's going down to the right. So it's skewed to the left and skewed to the right. That's how it's kind of talked about. Bimodal, you have 2 of them that are not together but have equal height. and they have to be separated by at least one class. Once again, how often that happens is very rare. So I just wanted to talk about those types of histograms. And then there are two other things left, actually three. Relative frequency histogram. Relative frequency compared to frequency, just think percentages, proportions. Okay? To calculate relative frequency, you just take the class frequency over the total. Okay? It becomes your percentage, how much you get right out of the total. It's the same idea. So for going back to the distance one, the first class had 6 out of the 25 entries were in the first class. So 0.24, and you leave it as a decimal. The next class had 5 out of 25, 0.2, and you leave it as a decimal. Okay? So here's a relative frequency table. You have your class and then your relative frequency. Here is a relative frequency histogram. Notice the boundaries and all that stuff is exactly the same. What's different about it? Instead of having the actual frequency, you have the relative frequency, and it's just the percentage. It should look identical to the original frequency. It's just now you have percentages instead of the actual number. So that process is very similar. Okay? Frequency polygons. Now I'm going to jump to a different example too, so I know this might get frustrating, but you take a class, dots are placed over the midpoints. Okay? So instead of having your histogram with bars, okay, you are now going to have actual midpoints in the middle of them, and you can imagine that these things are magically erased. It's just the dots left over. Okay? So over the midpoints of each class, dots are joined by line segments. Almost kind of looks like a line graph if you want to think about it that way. The only difference is the 0 frequencies have to be on each end, where the next class to the left and the next class to the right would become. Okay? So here's an example. Totally different example than the mile or distance one. The reason I chose it, it's really easy. What's the midpoint between 2 and 4? 3. Midpoint 5 and 7 is 6, 9, and 12. Those where the dots are. At 3, notice there's a dot. What's the dot? The frequency in that class. The dot at 6, the frequency in that class. Okay? And so on. Now notice that the next midpoint, notice they're going by 3, would be at 0 and would be at 15. So at 0, you need to have a dot on the horizontal axis, and at 15, you need to have the dot, and then that encloses your polygon. So this is a frequency polygon example, and that's how you deal with it. That's what the midpoints are for, and then it ends up enclosing in a shape. Okay? Oh my goodness. Okay, last one. I promise I'll be done yapping pretty soon. Okay, cumulative frequency tables. Now notice it's cumulative frequency. All right? So you're going to add it up like a cumulative GPA. You add it up over the course of your high school career. Okay? It's the sum of all the frequency up to and including that class, and that's usually how it's stated in the book. So here's a histogram, okay, that I have given you. And then notice that A, B, you kind of got to filter it in, see which one's which. But what is the cumulative frequency less than 390.5? Well, the histogram doesn't start there, so it's 0. Then you just tack on one more class. Less than the 490.5 is 5. Then 5 and 14 make the 19. Tack on 19 more is the 38. 22 more is the 60. And all that is cumulative adding up as you move farther right in the histogram. Okay? And then you can take this cumulative frequency table, okay, and you can end up making the graph representation of it, which we call an ogive. Okay? The ogive is just the graph of the cumulative frequency table that we made on the last page. Okay? And if you look at them, they should correlate with these dots. Alright? And you don't necessarily need this line. I'm fine if you leave it out, and then it's just this line going up and stopping there. Or if you want to go back down to 0, you can. Okay? So that is a whole bunch of information. You may want to kind of sift through it. There's a lot of information that you're going to need to know for your test and stuff. The last thing that is talked about that isn't graphically shown is a dot plot. Okay? It's just shown on a horizontal axis. Okay? Each data value is plotted with a dot or maybe multiple dots. And we'll talk about this in class. They're stacked on top of each other if they're repeated. Number 74 has an example. This is a problem right in the book that we can kind of look over in class. So there's a whole bunch of different representations. I know this got long. Thank you for following along and listening. This is the assignment that we're going to work on. I believe the only major heavy duty talking written out ones is 1 and 7. I'm not going to ask you to do a whole lot of that. I just want to make sure you understand the vocabulary part of this section. So thank you for listening, and we will see you in class.